Welcome to Vodcast 3. Our topic for today is solutions, acids, and bases.
I'm Miss Sandary.
And I'm Miss Varney. At the end of this chapter, you will be able to define and identify the solute and solvent in a solution,
Compare and contrast saturated, unsaturated, and supersaturated solutions,
identify the properties of acids and bases,
draw and correctly label a pH scale.
and identify common acids and bases.
Let's start with solute and solvents. Both these definitions should be in your notes. A solute is a substance whose particles are dissolved in a solution, whereas a solvent is the substance which does the dissolving.
So let's take the example of sugar water. Since sugar is the particles, or are the particles that are being dissolved, they become the solute. Since the water is doing the dissolving of the sugar, it becomes the solvent. Now there are different types of solutions. They're classified by how much solute a solvent can dissolve. So remember, solute is being dissolved, like the sugar in our sugar water example, and a solvent is doing the dissolving, like the water in our sugar water example. So there are three different types.
Unsaturated solutions contain less than the maximum amount of solute.
So if we had our sugar water example, an unsaturated solution would have not very many particles of sugar in it.
A saturated solution is a solution that contains as much solute as it can dissolve.
Okay, so going back to our sugar water example, it would have more particles of sugar than the unsaturated. However, all of those particles will be fully dissolved and you would be unable to distinguish sugar from water in that solution.
A supersaturated solution is where there's more solute than can be dissolved.
So supersaturated solutions have the most particles of sugar, and in fact, not all of those particles are fully dissolved.
So a supersaturated solution, if you were to see a glass of sugar water that was supersaturated, you would actually see particles of sugar resting at the bottom of the glass.
Exactly. So in these first two solutions, even though I've drawn in these particles to show you relatively how many particles are in the solution, you can't actually see those particles in this one, which is unsaturated right here, and then saturated, which is here. But in the supersaturated, not only does it have the most particles, but these particles are also visible. So make sure you write down these definitions as well as these drawings in your notes. So let's continue on to our next topic, distinguishing acids and bases. Water can be broken down into two different ions. We have a hydrogen ion that has a positive sign, and then we also have a hydroxide ion, which is negative. So this is important to remember because this is how we're going to distinguish acids and bases.
Alright, acids produce hydrogen ions when dissolved in water, and bases produce hydroxide ions when dissolved in water.
Okay, so we're going to remember acids, hydrogen ions, bases, hydroxide ions. Make sure you have that in your notes. That's an important distinguishing factor. Alright, so just as a review, acids produce
hydrogen ions in water. Remember that plus sign is a charge, and if you have a positively charged ion, that means there's more protons than electrons.
Exactly right, Miss Sandary. Alright, there's several other properties of acids that we need to remember. First, sour taste. Lemons are acidic. They taste sour.
Reactivity with metals. If you've ever heard of acid rain on the news, many people are concerned with acid rain because any precipitation that's too acidic reacts with metals. So that's our cars, our buildings, and our bridges.
Yeah, it can be a really big problem. And also the ability to produce color change on indicators. Indicators tell us whether something is acidic or basic. So acids produce certain colors on these indicators depending on how strong or weak the acid is. So here's a couple examples that you can write down in your notes. Any kind of citrus fruit like lemons, oranges, those are going to be acidic. Tomatoes are also acidic as well as batteries. So make sure you write down these properties and these examples. Alright, as a review, bases produce
hydroxide ions, which is OH minus.
And again, that charge means that there are more electrons than protons because it's a negative charge. So there are several other properties about bases that we need to remember. One, they have a bitter taste. So black coffee, not a frappuccino or cappuccino or something that's had sugar added to it.
If you've ever had black coffee.
Yeah, if you've ever had regular old black coffee, it's very bitter tasting.
The next one, a slippery feel. So if you do your own laundry or and you've used detergent, it has that slippery feel. So like when you're washing your hands, soaps are also bases.
Yeah, so soaps and detergents are bases and they have that slippery feel. Also, bases produce color change in indicators. However, they produce different color changes than our acids. So some examples that we talked about soap, detergents, as well as ammonia and baking soda are two other examples of bases. So make sure you write down those properties and those examples in your notes. Alright, so let's talk a little bit about the pH scale. The pH scale measures how acidic or basic a solution is.
It's represented by a line numbered 1 through 14. So depending on how acidic or basic a solution is, it's designated a number that says exactly how acidic or how basic it is.
Yeah, in fact, 1 through 6 is designated acids. 1 being the strongest acid, so it's the furthest to the left. 1 is the strongest acid.
Like the acid in your stomach that breaks down all the food you eat.
Exactly right. And then 6, the closest to 7, is going to be the least acidic. We call that a weak acid. And 7 in the middle is neutral.
Bases range from 8 to 14. 14 being the most basic substance, and an 8 would be a weak base. Your blood is actually slightly basic. So if you've ever had an IV before, it's really important that the solution that they put in your IV has the same pH as your blood.
Yeah, so again, stronger the acid or bases, the closer to the end of the scale they're going to be, and the weaker they are, the closer to neutral the acids or bases are going to be. So just remember, strong is further to the outside, and weak is going to be closer to neutral in the middle. So, for example, we have lemons, which are pretty acidic, and then we have tomatoes, which are also acids. Water is an example of something that's neutral, and then our common household detergents and soaps are an example of a base. Alright, so a little bit more about the pH scale. We're going to go into a little bit of how the hydrogen ions and the hydroxide ions play into acids and bases. So it's going to be really important to write this down in your notes. Okay, so we have this picture here. Alright, so acids, we're going to call this 7 on our number line because that's neutral. And then as we remember, 1 through 6 is going to be acids, so we're going to put 1 on this side. And 8 through 14 is our bases, so we're going to put 14 on this side because we have our bases over here and our acids over here. So I'm going to talk about acids and I'll let Miss Andere talk about bases. So the lower the pH, so 1 is a very low pH, the more hydrogen ions are going to be found in the solution. So let's say this is a sample solution. Because there's more hydrogen ions, you know that this is an acid. There's very few hydroxide ions. The more hydrogen ions there are, the more acidic. So this solution would probably be pretty acidic because there's a lot of hydrogen ions.
Yes.
So 7's in the middle, but I'll let Miss Andere talk a little bit about bases.
Okay. Bases, there's going to be a higher proportion of hydroxide ions to hydrogen ions in a basic solution. So if you have a pH of 14, there's going to be more hydroxide ions than if you had a basic solution of 8. There would still be more hydroxide ions, so there would still be more OH minuses than hydrogen ions. However, something with a pH of 14 is going to have even more hydroxide ions. And then if we have a neutral solution such as water, there's going to be equal amounts. So it would be like a 1-to-1 ratio.
So there'd be equal hydroxide, and hydrogen ions. Just drawing that 1-to-1 ratio. So the higher the pH, if there's a higher pH, you know that it's a base, you know that it has more OH minuses or hydroxide ions. That's the important thing to remember. If you have 1 to 6 pH, you're going to have an acid, which means that there's more hydrogen ions. That's the important takeaway from this slide, is the proportion of hydrogen ions or hydroxide ions depending on whether you have an acid or a base. And if we're at 7, which is neutral, it's going to be 1-to-1. There's one more thing that we're going to cover in this for this topic. It's going to be buffers. Buffers, we just want you to write down the definition and kind of know what it is. A buffer is a solution that is resistant to large changes in pH. So a buffer is not going to change pH very readily, so it is often used actually in our bodies to help us regulate the pH in our bodies. So just write down that definition, and that concludes our Solutions, Acids, and Bases vodcast. Have a great day.